Okay, so today, we're gonna tackle this, question. Uh, it's a physics problem. It's a projectile motion, that takes place on ground. So here we're given, an object is being thrown at 28 meters per second at 40 degrees, off the ground. Okay, so so the typical question that you get is, how long will the object be in air, and what is the maximum height that the object will reach, and how far will the object be horizontally be displaced. So in other words, how far will the object travel horizontally, and what is the final velocity of the object, and what is that you have noticed. So we have the vertical component set up, and then you have to have the horizontal component set up. So in the vertical component, the gravity plays a factor. So we're gonna have an equation that involves both the acceleration and the time and the velocity. At the same time, in a vertical component, the overall displacement is gonna end up being zero, because the object is being launched on the ground, and it's going to end up on the ground. So it starts off on the ground and it ends up on the ground. So what do we know about the vertical component? Well, we know the gravity is pulling downwards, so it's always accelerating downwards, and so it's going to be a negative value, so negative 9.8 meters per second square. Now we need to have a vertical velocity. So here we just need to use a bit of a trigonometry. So 28 times by sine of 40 degrees. That's the vertical velocity initial. So plug it into the equation. We get 0 equals 1 over 2 times by negative 9.8, and then time square plus 28 sine 40 degrees times by the time value. Now the horizontal component, we have a simpler equation where it's a displacement equals to velocity multiplied by time, and in the horizontal component, velocity is 28 cos sine 40 degrees. Okay, so now since we know how the vertical component has been set up, we need to find the time value. So to do that, you could factor out and simplify the vertical component equation. So time value turns out being without without turning the sine 40 degrees into a decimal, we're just going to put everything as it is. So 28 times by sine 40 degrees all over 4.9. It's going to give you 3.67 seconds. Okay, so the objective was in the air for 3 seconds and 67 3 seconds and 0.67 seconds. And this is the value that you can plug into the horizontal component to be able to get the horizontal distance traveled by the object. So now onto the horizontal component. So on the horizontal component, you have the initial horizontal component velocity, and you can multiply that by time. So when you multiply that by time, it gives you 78.72 meters. So in other words, horizontally traveled 28.72 meters. So in this case, question A and C has been solved and has been answered. So now we want to find the maximum height of the object. So in the case of maximum height, the equation that is going to be used is it does not involve time at all. So we have equation of velocity final squared equals to velocity initial squared plus 2AD, A being acceleration due to gravity, D being the distance that has been traveled by the object. So now, like when it comes to maximum height, the velocity of the object at the maximum height, it briefly reaches 0. So the final velocity is going to equal 0, and we know the initial velocity is 28 sine 40 degrees. So plug all of that into the equation, and you're left with one unknown, which is D. So manipulate it around, and then you want to find what the D is, the distance, the height that the object has traveled. So it turns out being 16.53 meters. Okay, so next we have the question of what is the final velocity of the object. Well, one thing that's nice about the horizontal velocity is that it's going to stay constant throughout the entire object, throughout the entire time while the object is moving. So horizontal velocity initial and final is more or less they're the same, and the vertical velocity it slightly changes, and that's mainly due to the acceleration due to gravity. So in one of the basic equation is velocity final is equal to velocity initial plus acceleration multiplied by the time value. So we know in a vertical component, we know the velocity initial 28 sine 40 degrees, and we know the gravity value, and we know the time value. Overall, that gives you negative 17.968 meters per second. Now, in order to, because you have both horizontal and vertical component, in order to get the final value, you have to put it into Pythagorean theorem, basically. And if you were to plug everything in, the final velocity, speed turns out being approximately 20 meters per second. So the final velocity is the same as the magnitude of the initial velocity. Okay, so now we also want to find the direction. So in this case, we would use 10, opposite over adjacent. So opposite, of course, being the vertical component, of the velocity, and then all over by adjacent, which is the horizontal component, and this gives you 39.95 degrees, and that's also 40 degrees actually. So in the end, the magnitude of the final velocity is the same as magnitude of initial velocity. The magnitude of the angle at the angle of the direction is also the same. So